Alright, so this is 11.2. We're talking about negative and Pythagorean identities. Similar to the last section, these are just identities for our sine and cosine functions that we can use to help simplify or reduce or verify our various trig expressions. For our negative identities, we have sine of negative x would give us negative sine of x. Cosine of negative x would get you negative or positive cosine of x, and then tangent of negative x gets you negative tangent of x. These are basically just three more identities you're going to have to memorize and use going forward. Now, because we have sine of negative x, that also means that the reciprocal would follow by the same rules, or cosine of negative x would get you a negative cosine of x, and secant of negative x would be the same as positive secant of x. And down here, cotangent of negative x would get you negative cotangent of x. For those needing to remember, just remember cosine is the one where the negative inside the parentheses becomes positive outside. Now, similar to what we were doing in the last section, we're going to have our different trig functions. We're going to try to simplify it down to one expression. So take what you have. If I have a negative angle here, well, negative sine of negative x is the same as negative sine of x. In my denominator, cosine of negative x would give me just a positive cosine of x. Well, from the last section, when we have sine divided by cosine, that gets us tangent of x. And since we have a negative and a positive, it is a negative overall. Same thing over here. We have negative tangent of x. That can be written as negative tangent of x, or alpha. Cosecant, negative cosecant, so that's times a negative cosecant of alpha. We have a negative times a negative. That gets us a positive amount. So positive tangent times cosecant. And we're going to want to switch each of these into terms of sine and cosine. So sine of alpha over cosine. Just like we did in the last section, cosecant is the same as 1 over sine. Cancel out or simplify where possible, and we're left with 1 over cosine. 1 over cosine alpha, which is the same as secant of alpha. Alright, now adding on to this, the other identities here are what are called Pythagorean identities. The reason they're Pythagorean is they come from a squared plus b squared equals c squared. Sine squared plus cosine squared would be the same as 1. Tangent squared of x plus 1 equals secant squared of x. 1 plus cotangent squared equals cosecant squared. All three of these identities can be changed around and used to substitute as needed. For example, here, I could change this to say that sine squared of x is equal to 1 minus cosine squared of x. All I've done is taken my equation and rearranged it as needed. These are going to be used to supplement and replace in our various expressions. So again, I'm going to use my Pythagorean identities to try to reduce and simplify here. First one, when I got tangent of theta, that's going to be the same as we said, sine over cosine times cosine of theta all over 1 over sine theta. Now you'll hopefully notice in the numerator my sine and my cosine will cancel out. I'm going to give myself some more room here. So when my sine and cosine cancel out, I'm left with sine theta over 1 over sine theta multiplied by your reciprocal, and you end up with just sine squared theta. Now remember, this is not the same thing as sine of theta squared. They are two different things. That is my first example. The second one on the next page. Alright, we're trying to verify our identity. Is going to be a couple more steps here. Take a look. My right hand side there, I'm going to want to leave that alone because that looks like the simpler one. So I have 1 minus cosine squared x. This here looks like one of our identities from the last page. 1 minus cosine squared of x. So that means this top portion I can just replace and say that it is the same as sine squared of x over cosine squared of x. Sine over cosine from our last is tangent. Now since they're both squared, I can replace it as tangent squared of x. My left hand side now matches my right hand side. We're verified. All right, and one more. We have example number 5 here. We got a lot going on here. Biggest thing, we have some squareds on the left, we have not squareds on the right. My top portion right here, this looks like something that can be factored. It's very similar to x squared plus 2x plus 1. So if I factor it using the same process, we'll get in our numerator sine of alpha plus 1 times sine of alpha plus 1. My denominator is still cosine squared at the moment. From our identities, cosine squared can be replaced. If I manipulate that sine squared identity, I can change that around so that the denominator will be 1 minus sine squared of alpha. This is going to be something that can be factored also. It's a difference of squares. So I'll give myself scroll down. We get sine of alpha plus 1 times sine of alpha plus 1. In my denominator, sine of alpha plus 1 and sine of alpha minus 1, difference of squares, so one is positive, one's negative. Well, now I have sine of alpha plus 1 in both the numerator and the denominator. That can cancel it out. I'm left with just sine of alpha plus 1 over sine of alpha minus 1. Now our left side has matched our right side, which makes it a verified expression. Alright, so now for your homework classwork, let me get a new page here, blank page. I'm going to give you practice problems, and they're just going to be problems number to work on. So your practice problems for classwork, homework, whenever we're getting around to this, would be numbers 1, 2, 3, 4, 5, 8, 9, and 10.